Hello, geometry students. This is Miss Green, and we are going to take a look at properties of parallelograms. This is in 6.3. We want to be able to, by the time we get done with this section, whoops, we want to be able to tell what is true about opposite sides, this one and this side over here. What's true about opposite sides of a parallelogram? What's true about opposite angles? And then what's true about consecutive angles? And then with that, can we apply this in some real world situations? Now, we're going to see if we can do a proof here, kind of an informal proof. We're going to look at if we can figure out something that's true about the length of the opposite sides of a parallelogram. So here's a quadrilateral. Quadrilateral means it has four sides. And I'm telling you that it's a parallelogram. That means you could put little arrows on here. So BC would be parallel to AD, and AB would be parallel to CD. All right, so I want to draw a diagonal here. And I'm going to draw a diagonal just goes from opposite corner to opposite corner. So BD is a diagonal. And you know that the diagonal is just a line segment, and a line segment can be made between any 2 points. So that's what we're going to do here. Now we're going to take a look at something that's alternate interior angles. Well, I just made a diagonal, and I could say that this angle is alternate interior to this one. And since these are parallel, I'm going to call this angle 1 and this angle 2. We can say that angle 1 is congruent to angle 2 by the alternate interior and angle theorem, alternate interior angles theorem. Now, I could also say, look at these. Oh, these two are, whoops. So if these are parallel, and that's a transversal, right? Those two are. But let's look at these two. These parallel lines and make this a transversal. So we're going to look at this one compared to this one using BC and AD as our parallel lines this time. So that's also alternate interior angles, and I'm going to call this 3 and this one 4. So I'm going to say angle 3 is congruent to angle 4. Now a reflexive property, I mean, that's like looking in the mirror and seeing yourself. Let me use another color here if I can. This BD, that diagonal, is congruent to itself. So BD, line segment, is congruent to BD. That makes sense. Now, I'm looking, it says ASA. So let me look. Angle, side, angle, angle, side, angle. Well, sure enough, that angle, side, angle says I have two congruent triangles, and I've got to be kind of careful about how I name these, but I can say triangle A, B, D is congruent to triangle C. Now remember 1 and 2, so the B would go with the D. So the B here would go with the D, and then 3 and 4 congruent, so the D on this one goes with the B on the other one. So kind of have to watch that a little bit, make sure you get it set up. Now I'm going to look at, what's my object? I want to look at the opposite sides. Well, I just proved these two triangles congruent. So if I look at AB in here, that's the first two, it would have to be congruent to CD. So I could make a mark there. AB is congruent to CD. Now what about AD, the first and the third here? That would line up with CB or BC. It doesn't matter which way you say it. Not for line segments. It does matter for the triangles. So those two are congruent. So these opposite sides here are also congruent. Well, I did kind of a backwards, kind of a little, not a backwards proof, but I kind of gave you the justification and we had to figure out the statements. But we can conclude through all this that the length of the opposite sides of a parallelogram are congruent to each other. And that's this theorem right here. It's saying that if this quadrilateral is a parallelogram, in other words, it tells me they're parallel, but you could write on here too. Oops, it gets weird when I get close to the end here. Sorry about that. You could just go ahead and put those on there. If that is a parallelogram, meaning opposite sides are parallel, then I can say the final conclusion is that the opposite sides are congruent. Well, here's a problem that we can try to solve. If that's true, given this parallelogram here, so I'm telling you that it's a parallelogram, and I'm giving you a couple sides, what is YZ? So this one over here, whoops. Well, we know opposite sides are congruent, so YZ would have to be 3.27. And it didn't ask me, but if it asks for WZ, you should be able to do that too pretty easily. That seems like a basic concept. We kind of know these things to be true, but we don't always go through all the proofs. Now let's look at some examples. So here's a quadrilateral, and we've got relationships between the sides that we know about, and then we know it's a parallelogram. So the sides are parallel, opposite sides are parallel, and we just figured out by the theorem that we just learned that QP would be congruent to RS and QR would be congruent to PS. So you might think, how could I find X? Well, there's several ways actually, because the opposite ones, you could say 7x minus 3 is equal to 2x plus 12. You could do that. And think about another way that you could do it. How about 4x is equal to 5x minus 3? You could do that, because those are opposite sides. Now use your algebra. I want you to go ahead and try this and see if you can figure out, is x the same for both? Because if it's not, we might have a little problem. So go ahead and try that. And I did find that x equals 3 on both of them. Yeah, we got another question going up. So x is 3, so that's good. Now it's asking for the length of each side of the quadrilateral. Well, really, I only need to find 2 of them because the opposite ones. So I'm going to pick the easiest one for my brain. If x is 3, 4 times 3 is 12. So that would have to be 12, and this would have to be 12. You can double check, make sure it works. And just because I don't like to subtract as much as I like to add, I'm going to let x equal 3 here. So 3 times 2 is 6, plus 12 would be 18. I might double check, but I can do it in my head. There you go. Here's a problem you can try. And I'm going to give you a little help. Whenever we have word problems, sometimes I like to do a little highlighting. So we have a 600-meter fence around a city park that forms a parallelogram. So the 600-meter fence, that sounds important. And it's a parallelogram. And the fence along Chaco Road is twice as long as the fence along Grover Road. So I'm going to do this twice as long as Grover Road. And then what is the length of the fence on Jones Road? Now I do that because that information, it seemed like it's probably important, and I need to be able to do something with it. So I have a chart here, and it's called a KWS chart. You've probably seen it. You might even call it something a little different. But the first thing is I would write in everything I know. So I would know that the perimeter, well, the perimeter is 600 meters. And then I'm going to say Chaco Road. Chaco is 2 times Grover, right? Because it told me that. And it's a parallelogram, so that helps too. All right, now what do I want to know? That's the question. I want to know the length of basically Jones Road, because that's the same as the fence on Jones Road. That would probably be a little more clear. Now, what strategies do I know? Sometimes these are formulas, or with what we just did, we had some theorems. So I know that opposite sides of a parallelogram, and I'm just going to write it like that, are congruent. So I would probably go ahead and mark on my image here. Whenever I know something to be true, that's congruent, that's congruent. Now, I did say Chaco is twice of Grover, so I might call Grover X, and this would just be 2X. Now, since that's congruent, this is 2X, and that's congruent, that's X. So now I can actually get to a little work here. So the perimeter is X plus 2X plus X plus 2X, right? And I set up here that that equals 600 meters. So how many X's do I have? 2, 3, 4, 5, 6. So I have 6 X's that equal 600. So I divide each side by 6, and X equals 100. And we measured in meters, right? So we'll do meters there. So what's the length of the fence along Jones Road? Well, that's X. So I could just answer X equals 100. Now, what do we know about angles in a parallelogram? Consecutive angles. Oh, sorry, I flipped that too fast. So these are parallel. This could be a transversal, right? And a consecutive angle is just angles that are next to each other. So A is next to B, so let's look at those. So if we kind of think of those as being lines, and this being a transversal, we have an angle here and an angle here, angle B and angle A. Oh, wait, I remember that angle A and angle B are same side interior angles. And since these lines are parallel, they are also supplementary. Same side interior and supplementary. That means they add up to 180. So the consecutive angles from here to here would be 180, and I could do the same thing over here, right? Those would be add up to 180. And I could also take a look at knowing that these are parallel, and this could be my transversal. So I extend my lines out this way. Now I have this is that one and this one are consecutive angles, and they must also be supplementary. So I have a whole bunch of pairs of angles that are supplementary. So angle A and angle D are supplementary. Angle B and angle A are supplementary. And I would also have C and D. Angle C and angle D are supplementary. That's an angle sign. And angle B and angle C are supplementary. Now, what about the opposite angles in the parallelogram? You could do a couple different things. There's a couple ways to figure this out. You could prove the triangles are congruent and something like that, right? And then the corresponding parts could be congruent. You could do that. Or I just said D was supplementary to A, and B is supplementary to A. And there was a theorem, it's been a while since we looked at that theorem. There was a theorem that said if two angles are supplementary to the same angle, then they are congruent to each other. So angle B is congruent to angle D. My squiggles, there we go. And then angle A and C would also be congruent to each other. Yeah, but you might think, well, if I drew that diagonal, and I know this is the same as this, and remember we had alternate interior angles, we went and we could prove that those two triangles are the same too. My side angle side, it's another way to prove, and then the corresponding parts would be congruent. So let's apply this this idea, this theorem that, well, we didn't do it's going to be laid out in a theorem here in just a minute, but we kind of casually proved it to be true. So if we have a given parallelogram, we want to know the measure of A and the measure of C. Those are opposites, so they must be equal to each other. That's good to know. But we also know that since they're consecutive, because it is a parallelogram, since they're consecutive, that they must add up to 114. So let's just call this, 180. Let's just call this x and this one x, because it doesn't matter. We know they're the same. We've already decided that. So x plus 114 would have to equal 180. Subtract 114 from both sides. And maybe you don't have to write this all out. Maybe you're fast enough now with your algebra, you can do this. So x would be 66. That would be 66 degrees. I'd probably double check 66, 6, 7, 8. Yep, I did right. So what's the measure of angle B? Well, that's opposite D. So these two guys are opposite each other, and we know that opposite angles are congruent. So that must be 114 degrees. Right. Okay, why don't you try this one, and we'll come back and see if we agree. Oh, it just jumps a little bit. Okay, here's what I found out. So I knew that A and C were congruent, so C had to be 64, and I knew consecutive angles had to be supplementary, so I found that this would have to be 116 and that would have to be 116. All right, so here's our two theorems, and these are things, if you don't have these written down, you'll want to write them down. It shows that all the consecutive angles are supplementary, and then that's only if it's a parallelogram, right? It has to be true. And then opposite angles are congruent to each other. So those are the important theorems from this section. Tomorrow we're going to do some more with the sides and the angles of the parallelogram. So just for today, that's all you need to know. And you should be able to do your 6.3a Math Excel. If you have any questions, it's really good to work with a friend to talk through some things, or ask your teacher, come to office hours, do something like that so that you can figure it out. And you know Math Excel has some helps on it too. You can also rewatch part of the video if you need to. Have a great one.